Hello everyone, and welcome to Network Playroom. This is the third video in the Christmas calendar series, and we're going to continue where we left off yesterday. To recap briefly, in yesterday's video, we looked at static and dynamic routing and how the routing table is built. In this video, we're going to discuss how the router chooses the best paths to install into the routing table and how it's going to route packets. Again, I want to emphasize that not all learned routes end up into the routing table and are used to route traffic. But now we're going to look at what gets into the routing table and why. So there are essentially three processes involved in building and maintaining the routing table in Cisco routers. So there are the various routing processes which run a routing protocol such as EIGRP, PGP, ISIS, and OSPF. Then there's the routing table itself, which accepts information from the routing processes and also replies to the requests for information from the forwarding process, which is the last one. So the forwarding process, which requests information from the routing table to make a packet forwarding decision. So let's examine the interaction between the routing protocols and the routing table to understand how the routing table is built. So this is essentially the diagram that I've shown on the screen last time that I've kept here for the purposes of this video. So if you look here again, we had EIGRP, OSPF, PGP, and static routing. And the best routes from those protocols would be installed into the routing information base or the routing table. So all of these are their own databases, and the best ones would get installed here into the routing table, the big star. Let's make it sparkly. The winners go here. So the routing table is a collection of the best routes. And what this means is that the router can learn about the same route or network from several different sources, but only one of them is installed into the routing table and used for packet forwarding. So, well, actually, there can be multiple equal routes in the routing table, but we'll ignore load balancing for the purposes of this video. Assume that only one route can be installed into the routing table. Now let's be clear, when I'm talking about a route, I'm referring to a network and prefix length. So for example, 192.168.0.0/24 is one route, and 192.168.0.0/16 is a different route, although the base network is the same. So let me write that down here. So 192.168.0.0/24 is not equal to 192.168.0.0/16. So in case this route was learned through EIGRP, and let's say this one was learned through OSPF, then both would get installed into the routing table. So the main considerations while building the routing table are number one, the prefix length, and this is what I've just explained. So these two routes are different. And then number two, administrative distance. So this is the measure of trustworthiness of the source of the route. So if the router learns about a destination from more than one routing protocol, the administrative distance is compared and the preference is given to the routes with lower administrative distance. In other words, it is the believability of the source of the route. So in this case, EIGRP would win over OSPF, for example. And each routing protocol has default administrative distance values assigned. I will show that later I have a nice document, a Cisco document open on my web browser. I'll flash it to you in a moment. But the administrative distance for EIGRP internal routes would be 90, and then for OSPF, 110. So since lower administrative distance value is preferred, so let's say now that, oh, not that one, let's remove this one. So let's say that this route was learned through both EIGRP and OSPF. So now, because of the lower administrative distance, the EIGRP route would win, and that would be installed into the routing table. And OSPF would be just left into the database, and it would not be used to forward packets. Okay, and then finally, number 3, there's the metric. And this is the measure used by the routing protocol itself to calculate the best path given to a destination, if it learns multiple paths to the same destination. And each routing protocol uses a different metric, so you can't compare them between routing protocols. So again, for example, EIGRP and OSPF use completely different metrics, so you can't compare them between each other. This would not happen. But in case, let's say that, let's look at R1 on top here. So let's say that it learned this route from R5 and R2. So I'll just write number 1 because it's easier than typing that whole route. So let's say that they would have different metrics. Let's say this one's 50 and this one's 20. So because of the metric, the lower metric, this route would be the preferred EIGRP route. So as each routing process receives updates and other information, it chooses the best path to any given destination and attempts to install this path into the routing table. So all of these routing protocols, they're like, pick me, choose me, and then it's up to the routing table to decide, or really the router to decide what it's going to install into the routing table and use for packet forwarding. So the router decides whether or not to install the routes presented by the routing processes based on the administrative distance of the route in question. So if this path has the lowest administrative distance to the destination, it's installed into the routing table. So I already described that to you. So if you have this same route, so both EIGRP and OSPF advertised this route, then by default EIGRP would win. But if they advertised different routes, they would both be installed because they are unique routes. So, but again, if there are multiple paths to the same destination from a single routing protocol, then the multiple paths would have the same administrative distance, and the best path is selected based on the metric. So this is what I explained with the example here on R2 and R5, advertising this route with different metrics. So this one would be preferred. And then finally, there's something important to note, that packets are distinctly forwarded based on the longest prefix match. So for example, a packet destined to 192.168.0/.15 would be forwarded using the EIGRP route instead of the OSPF route 192.168.0.0/16 because of the longer match. So let me change this to number 2 again. So let's assume that route number 1 is advertised by EIGRP and route number 2 is advertised by OSPF. So now, if there's a packet destined to 192.168.0.15, then it would use route number 1. But then let's take, for example, 192.168.42, because that's the answer to the universe, dot, I don't know, 117. So that would now use route number 2, or it would be forwarded using route number 2. So that is something to keep in mind, that by default, IP routing is destination based. So you always look at the destination IP address to make a forwarding decision. And the longest match wins. And let me jump to that document that I promised, this Cisco document called What is Administrative Distance? So a lot of what I've just explained is from this document, but here is the table that I wanted you to look at. So here it lists the different default administrative distance values for different routing sources. So if we look at it briefly, so connected interface, the default administrative distance would be 0. So that is the most trusted route. And then right after that are static routes, and then EIGRP summary route, and then PGP routes, external PGP routes, and then EIGRP, OSPF, and so on. And these are just default values. You can actually change them under the routing process with the distance command. But if you do this, then you need to make sure that the distance is consistent throughout your network. Otherwise, you can have weird behavior in your network, and you could potentially create routing loops, because some routers might prefer other routes than to what you intended. So yeah, don't do that unless you've planned it carefully and you really have a need for it. But to summarize, so there are two different things really what we've discussed here. So how the routing table is built and how packets are forwarded. So the latter one is maybe easier to internalize. So packets are always forwarded based on the longest prefix match. And by default, routing is destination based. And then the routing table is built, well, based on the prefix length, as we discussed, like those routes are different. So again, this one is important to understand, that these are different routes. And even though this route fully covers the range of this route, wow, I have a lot of arrows pointing here and it's getting a little messy. So yeah, so even though this last 16 route fully covers this last 24 range, they are still different routes. And then after that, the routing protocols themselves, they compare the metric in case they learn the same route from different neighbors, or they have multiple paths to the same network. They use the metric inside the routing protocol to decide which one is the best for that protocol. And then it's like the router, putting up its hand. It's like, hey, pick me, choose me, this is my best route. But then what actually gets into the routing table is based on the administrative distance. So the router goes, oh, well, hey, EIGRP, I like you more than OSPF. I trust you more than OSPF. I'm going to put your route into the routing table and use that for packet forwarding. So that's really how it works. Hope that didn't get too messy for you guys and you were able to follow my ramblings. So thank you for listening, thank you for watching, and I'll see you in the next video.